there's a tipping point possible on the horizon where this material, concrete, that's responsible for so much of the planet's emissions could actually flip around and become a place where we're actually storing carbon and really change the trajectory, not just for construction, but of the sort of climate efforts in all parts of the world.
Welcome to the Fine Homebuilding Pro Talk podcast, our regular discussion with building industry professionals. This is Fine Homebuilding contributor and production manager at TDS Custom Construction, Ian Schwandt. Today I am joined by Chris Magwood, Director of Research at Builders for Climate Action. You can find the Fine Homebuilding Pro Talk podcast and the original Fine Homebuilding podcast at finehomebuilding.com/podcast. You can leave feedback and ask questions there as well. Chris, thanks for joining us.
Yeah, my pleasure. I'm glad to be here.
Chris, can you tell us about your background and the work that you and your coworkers do at Builders for Climate Action?
Sure, yeah. The Builders for Climate Action project actually started with us at the building school called the Endeavor Center, trying to, for ourselves, figure out what the carbon footprint of the materials in our own building projects might be. We had been focusing on a really kind of metrics-based way of evaluating our, version of green building. So, we had figured out, how to use energy modeling software to figure out those metrics, and we were measuring our job site waste and our power use on site, and even things like the number of materials that contain questionable chemicals. So we were kind of attaching numbers to all of these things and realized that the one thing that we didn't have a clear understanding of was the climate impact of the materials themselves. And so back in 2012, we tried to figure that out for one of the projects we were doing and realized that this was not an easy thing to figure out at the time. The data was kind of limited and scattered and came through lots of different lenses, so made it hard to compare things. But I think partly because it was so difficult to figure out, I got a bit obsessed with trying to figure it out. And in 2016, I actually decided to go back to school and do a master's thesis so I could really concentrate on this. And around that time, there was also a bit of an explosion in the production of these documents called environmental product declarations that are kind of that comparable look at emissions from the production of materials. And so I did a study of a couple of building types, residential building types, and was able to characterize all the materials that would go into the structure and enclosure and partitions for those buildings, and sort of show that depending on which materials you chose, the exact same building with the exact same level of performance could either have this massive climate impact or a very small one, or even a positive climate impact by storing more carbon than was emitted in making the materials. And so that kind of finding spurred us to start Builders for Climate Action, to start sort of working on this more, publicizing it, and we eventually released the tool that I had developed to do that study as a publicly available free tool called Beam. And so ever since 2019, when that first study came out, this is what our team's been working on.
I first found out about your work being involved in NESI, in the Plan Big group, and the people from New Frameworks were involved in that. And I remember Jacob Rasmussen brought in a very early version of the Beam tool. I'm sure it's not even remotely similar to what the final tool was, but it was interesting to put some of our remodeling projects through that tool and start to understand the embodied carbon. Can you talk the listeners through that tool and how it works along with those product declarations?
Sure. So yeah, the environmental product declarations, or EPDs for short, they kind of it's an ISO standardized way of accounting for emissions from materials. So it attempts to draw the same boundaries around, all the products in a category so that the same things are being counted in the same way. And essentially you get from an EPD an amount of emissions per a certain amount of material. But then in order to actually apply that to any given building project, you have to know how much of that material you're using in the building and sort of multiply it appropriately by however the factor in the EPD is being used. And there's variation in those factors. So sometimes an EPD will give you an amount of emissions per weight of material or per volume of material or per effective use of material. And so there's this kind of other math you need to do to be able to convert those emissions factors by an amount of material in a building. So essentially, that's what the initial version of the tool did, and that's what the current one does. Is sort of it kind of builds in the material takeoffs based on building dimensions and tries to really simplify that background math. So all of that happens behind the scenes. So you just tell the tool, I'm using this many square feet of this material, and it will kind of do the calculation behind the scenes, and it gives you the results. It's a spreadsheet, so it gives you the results of all the different competing materials within a given category beside each other. So if you say I want R20 of insulation that covers 1,000 square feet, once you sort of set those parameters, you will see the climate impact of all the different materials for which there is data available beside each other. And so that way it becomes really obvious, which are the high emitters and which are the low ones. And so to build out a model, you basically then just start clicking on the, checking the box next to the material you're going to use for your building. And it kind of builds up a cumulative look at what the emissions would be for all the materials in the building or for whatever assembly you happen to be wanting to model.
So you can use the tool then to, say, select the difference between using an XPS insulation on the exterior of your building versus the improved carbon performance of the building if you were to use something like a wood fiberboard exterior insulation.
Yeah, so from Beam you'll get the material emissions difference between those two, and to figure out the performance difference, you'd have to also combine that with an energy model. Within Beam, you can kind of set those R values to be the same, so you should, in theory, be getting the same performance out of R10 of either of those two materials. But typically, if you're trying to look at the impact on the climate of your materials compared to the impact you're having by doing an energy efficiency upgrade, then you'd need to sort of have both. And a common version of that is people will look at the difference in embodied carbon between, say, double pane windows and triple pane windows. So you can go, okay, it's, if I do this house in triple pane windows, there's X amount more emissions than if I did it in double pane. Let's go over to the energy model and see what difference those triple pane windows make in the operating emissions and find out how worthwhile is that. Is that going to realize the operating savings in a year or in 20 years? And then you can start to make some decisions, based on the relative difference between those two.
I think that was one of the things that struck me most when I first got to understand the theories behind embodied carbon and where the production of the given material that you're using also needs to be taken into account. I think it's easy to just look at, let's load a house up with insulation, let's put better windows in, and it's just we're building a product that's better for the environment. But a lot of your work is more focused on the other half of that story of where our materials come from.
Yeah, and I think sometimes those two halves are kind of presented as being in opposition to each other, right? Like you either have to focus on embodied carbon or you're going to focus on operational. But I think all of our studies have been really clear in, saying you can do both. Like it's in most cases, you can choose a lower embodied carbon version of a material to achieve the same, operational ends. And so there isn't necessarily a trade-off of one to the other. In the town of Nelson, BC, we did a study of 35 homes that had been built in the town in the past year. And they have an energy step code, sort of, a base of 1 up to a high performance level of 5. And what we found was when we did the embodied carbon models, it didn't matter where the house was on the energy step codes, that a really high performance house could have a really low embodied carbon, a really low performance house could have a high embodied carbon, or anything in between. So it wasn't, that the level of energy performance isn't a predictor of the embodied carbon. One doesn't have to go up with the other. And so I think that's where the beam tool is really important, is like not to say, oh, we should now stop focusing on operational emissions. It's like, how do we keep our eye on operational emissions? And like those have to get to zero too, but how do we also look at doing that kind of simultaneously to reducing the embodied emissions?
I think it's easy for builders who are accustomed to the material decisions that need to be made in a project to understand the beam calculator, and I think it's pretty great that the tool can help you make a better informed decision. So I think we all know how to help somebody pick out tile, or how their kitchen layout or design influences a project, but I think too many times you get sort of lulled into, my local supplier has this, it's easy for me to get, my my tradespeople know how to work with it. But some of the materials that you have in the beam calculator, especially insulation wise, oftentimes can be switched out without much consequence. One of the things that I took away from the earlier versions of your calculator was the embodied carbon level in concrete. Can you talk at all about some of the work that was done in your studies to reduce the amount of that high embodied carbon material usage?
Sure. Yeah. I mean, in all of the studies, concrete has most typically accounted for about a third of the carbon footprint of all the materials in a building. So it's a sizable contributor. And I guess there's kind of two ways that can be addressed. One is by focusing on the actual carbon footprint of the concrete mix that you're ordering. So there's a big difference between a standard concrete mix of Portland cement and aggregate, and a mix that has a high percentage of something like slag or fly ash or something like that put in it as a supplementary cementitious material. So a high SCM mix can have 30-40% less carbon emissions than a standard mix, has the same functional value, like the same strength properties and everything like that, and typically doesn't cost more. So there's a fairly straightforward substitution path where you can really cut that down. And then there's obviously the more complicated path of, can you use less concrete? And so, when we looked at some models for the city of Vancouver, one of the big places where we can make a difference is replacing concrete slab floors with the kind of like slabless slab that I know has been featured in Fine Homebuilding and other places, of eliminating the concrete and kind of using a doubled up plywood. And that was a great way to reduce a huge amount of the concrete in a building. So depending on where you want to go, it can be as simple as a mix substitution and you just keep making the same building the same way, or you could do a mix substitution and some concrete reduction or minimization and have a big impact that way.
When I was in the Plan Big group with Jacob, I remember somebody asking him, like, what is the one thing that we could do more of to reduce the carbon in our buildings? And he just immediately replied with, use more plants. And then that that did lead us into more of a discussion about carbon storing materials, which I think the first time you hear that as a builder, it's a little bit difficult to wrap your head around the idea of a material being looked at as a carbon storing material.
Yeah, and I think it's complicated by the fact that in my own work and in the beam tool, the most common plant material in buildings, wood, we
Right.
don't actually attribute any carbon storage to wood, and there are lots of reasons for that. Mostly just there is no actual proof that says that putting wood in buildings is a benefit to the climate. I mean, you're undoubtedly putting carbon atoms that came out of the atmosphere into the building, but because of the way the accounting happens for emissions from wood, we don't count the wood that never made it into your building and probably got burned in the kiln and went back up into the atmosphere. So if half the volume of a tree makes it into your building, but half the volume of the tree, the carbon went back to the atmosphere, there's no net storage happening in that building. We don't typically count the root mass of that tree. And so there's another 20% of the tree that's also going to rot and go back to the atmosphere. We don't count carbon that comes out of the soil when we disturb forests by harvesting them. So I'm not convinced that wood isn't necessarily carbon storing or can't be, but I think the way that we calculate it now, it's difficult to make that assumption, and so we don't. But there are all kinds of other plant-based materials where the climate math is much more straightforward. And I think, the easiest one to point to would be cellulose insulation, which is something that, builders have been using for quite a few decades. And, that newsprint or cardboard that is in the cellulose, that was, plant-based carbon that was about to go back to the atmosphere. It had been thrown in the garbage or thrown in the recycling, and it was going to become either incinerated or landfilled and go back to the atmosphere. If we put it in a building instead, then we've stored carbon. Or if we can take a residue from agriculture like straw that also, grew in a year, we were already going to grow it. We took the grain off, we ate it. There's this, carbon storing bit left over. If we put that in a building, then, we can say, yeah, that's meaningful carbon storage. Or, materials that are purpose grown like cork or hemp or something like that. Same idea. You have short annual crop rotations. That carbon was likely to go back to the atmosphere. If it ends up in the building for, decades or a century, then you've, made a meaningful carbon removal. And so, there's a whole sort of slew of different materials out there that do that, some of which are, within the sort of typical conventional realm, and a lot of which, are kind of considered more alternative, but are certainly every bit as feasible as the things we build with today.
Do you see a place for, you talked in concrete, changing the mix? Are there any uses for these rotational, quickly grown crops to where they could become part of something that we're already using as a way of reducing the carbon footprint of a material?
Yeah, absolutely. There's really interesting work going on right now. In fact, Prometheus Materials has a concrete block where the concrete part is actually made grown with algae. So you have algae pulling carbon out of the atmosphere, and instead of turning it into a plant, it's turning it into calcium carbonate, and so they will have a concrete block product out, and hopefully they're hoping for a ready mix product where the cement itself is carbon storing. You have places like Blue Planet that's making aggregate for concrete out of CO2 that it's extracting from smokestacks and turning that into calcium carbonate again. There's a tipping point possible on the horizon where this material concrete that's responsible for so much of the planet's emissions could actually flip around and become a place where we're actually storing carbon and really change the trajectory not just for construction, but of the sort of climate efforts in all parts of the world.
I think with the material like concrete that's in so many of the products that we touch and so many of the things that we build, is there anything that the free market is doing with some of the availability of the raw materials that's helping kind of bring some of these new things to the forefront, like the concrete block you talked about, or the different kind of aggregates being made?
Yeah. Maybe not so much the free market, but certainly the IRA that was just passed in the U.S. There's billions of dollars in there for the federal government now to specifically tag to procure low carbon versions of construction materials on federal projects. So, suddenly the factor on an EPD for concrete is going to become one of the deciding factors for whether the federal government buys, millions of dollars worth of it or not. And so that, I think, is going to really help spur competition for, coming up with lower impact versions of concrete. The Canadian government is set to do the same thing starting next year. So I think those kinds of nudges to the market will really help. And similarly, there are some corporate buyers of those materials now. Some of the big tech companies and stuff also making those sorts of commitments. Like, we are going to buy the low carbon version of these materials, even if they cost more, to sort of spur that market. So I feel like, in the last just couple of years, the amount of sort of intent and interest around this has really it's evolved really quickly, and I think it's going to be one of the main sort of levers on the market.
I think it's easy for those of us, especially in the single-family home or small construction industry, to forget that large governments and large multinationals are some of the biggest purchasers of construction material. And we're talking about ways that small builders can maybe do better by using your tools to swap out different kinds of insulation that could have a major impact on their projects. But is there any place that you would suggest the small individual builders that maybe only do a handful of projects a year where they should start?
Yeah, I think, we've done sort of 4 big studies here in Canada now for, different levels of government and looking at, buildings in different climate zones across Canada. And the results have kind of always been the same. Basically, if you can knock off something off the carbon footprint of your concrete, probably not by going and getting Prometheus blocks, because you probably can't get them or afford them, but by talking to your concrete supplier and saying, like, what is a feasible amount of, slag or fly ash or something like that could go into this mix. If you can take 30 or 40% off that material's carbon footprint, that's huge. You could look at, subbing some insulation products, like cellulose for some of the other ones that you might be using. Things in the interior of the building, flooring, those sorts of things. There can be a huge range in the carbon footprint of those. And even just if you think on the level of procurement alone. So we did a study for Doug Terry Homes, which is a sort of medium-sized developer here in Ontario. And for their buildings, we showed them that there was a 20% reduction in carbon footprint, not even by switching materials, but by just paying attention to what's the lowest carbon version, from a manufacturer of that product. So switching, Rockwool company A to Rockwool company B, or drywall company A to B, made a 20% difference in the carbon footprint of one of their standard plans. And so, it doesn't even have to be as complicated as I'm going to change my materials. It can just be, I just need to source the one that's got the lowest carbon footprint. And quite often those things are sitting side by side on the shelf at the,
right.
At the retailer. they do the same thing, they cost the same amount, but one might have twice the carbon footprint of the other. So just, and I think that's a place where BEAM can really help, because you can go in and go, oh, I didn't know that, this brand would be a much better choice than that brand. So even at that level, I think there's a lot that the small builder can do.
I think the point you make about the two products might even be sitting on the shelf right next to each other is one that oftentimes gets lost on people. You think you run into a big box store and you see a couple different types of insulation board or bales of insulation there, and you just assume that they're pretty much the same. When you talk about the same product but between two separate manufacturers, are you getting the carbon footprint info directly from the manufacturers?
Yeah, so the EPDs that we use, they typically come from a specific manufacturer, so that's their data. It's been third-party verified, but it's the numbers that the company themselves have kind of assessed from their own operations.
So is there any other really easy low-hanging fruit that smaller builders can go for, or is it really just seeing what's available locally and just making better decisions?
Yeah, for Doug Terry Homes, we kind of showed them, I think it was 6 different substitutions. So better concrete, switching to cellulose insulation, switching to some best in category things like, drywall, some of their flooring options. And, we got a 60% reduction in the carbon footprint for that small number of changes. And when they looked at that, they're kind of cost neutral in terms of a couple of them, there's no price difference. A couple were a bit higher, a couple were a bit lower. So you could kind of institute those changes for no real difference in the cost of the project. But I think, for builders, we've all been doing this same thing for a long time, right? When you think about energy efficiency, I mean, you could just make the most energy efficient house every time, but you don't, because there are other factors that you have to weigh in, like cost and trades and all of those things. And I feel like, the embodied carbon piece is just, it's one more thing that you throw into that mix. Like, we don't always choose the lowest embodied carbon product in every category, because there are other reasons, that we might choose that. Availability or durability or cost or, something like that. So I think, builders have long been able to sort of do that juggling act. And this is just sort of one more ball to kind of throw in the air as you're making those decisions.
Right. Yeah. One more decision to have to make, or, one more thing that you have to weigh against a different decision that, as you put it, we're doing that all day long as a function of our business already. I think it's telling that you can take a company that's building that many different homes and make revenue neutral changes to their procurement. I think that really kind of, in my mind, of being more cost focused, it shows that energy efficiency in the low carbon building doesn't necessarily equate to a higher construction cost.
Yeah. And I think, similarly to the kind of price differences we've seen in other parts of buildings, it used to be triple pane windows were, horribly more expensive than double pane. But the fact is, like, as more people use them, the price comes down. And I think for a lot of the low carbon materials, we'll see that happen too. Right now, sometimes they're priced higher simply because, the sort of production volumes aren't as high, or the availability is not as high, but there's no reason that they're necessarily more expensive. And as more people decide to choose them, the price will actually come down, as with solar panels and, so many other the parts of the building that, we've applied some pressure to get to better performance levels. And the price comes down as that happens. And I think we'll see the same with embodied carbon in materials.
Have you done any work to your own home that is reflective of the research that you've done? Anything that you've remodeled or changed because of the things that you've learned?
Well, it's interesting because the home I'm in right now is the one that kicked off our just trying to figure this out in the first place. So it's a straw bale house. It's one that we made from panels that we prefabricated offsite, and so we didn't necessarily have all the numbers at that point for what the carbon footprint was, but we had a pretty good idea of what the good choices were going to be. And so, we actually intentionally, made a house that used as many of those as possible.
Have you found that the decisions that you made stood up against the data that you put together later on?
Yeah. And sometimes surprisingly so. Like when you actually do the calculation, say on a straw bale wall, it's kind of shocking how much carbon it's storing.
Right.
And a few things that were maybe a bit of a surprise, like we used an insulated concrete form. At the time it was called Durasol. It's now called Nexem, but it's like a wood chip in cement ICF block with a mineral wool insert. And it turns out that it wasn't that much better than a normal concrete wall with a typical insulation product on it. A little bit, but not as much as we thought. So there were definitely some surprises, but we had a pretty good sense that the things that were going to turn out well did when we were able to model them more accurately.
And the same thing could be said for the energy model of a straw bale house?
Yeah. In fact, that almost always the performance turns out better because the assumptions around the R value of a straw wall are generally lower than the real world performance. So, and one of the things that we learned with this place was how to go about making a straw bale house airtight, because lots of insulation is great, but if it's
right,
surrounded by lots of leaks, the performance isn't that great. So, we were able to get this house down to pretty close to a passive house level of airtightness. And so, that was our first step in how do we combine those two things, like this material that we know does, some great things on the embodied side, but making sure that it wasn't a sacrifice on the performance side.
Well, it's been great talking to you today. Is there anything else that you want to tell the audience or direct them to of work you guys are doing at Builders for Climate Action?
Yeah, I think if people go to the website, all the studies that we've done are there, and we tried to make them illustrated and reasonably easy reads. And I think the takeaways have been pretty consistent across all of them. So I think there's some really great information there, and to just consider giving Beam a try. It's easy. I'm not a software person, and we made Beam so that even I could figure it out and use it. So it's pretty approachable. If you've worked on a spreadsheet before, it's not very intimidating, and worth checking out for just some of the really easy takeaways that you'd get just from playing around with it for a few minutes.
Yeah, and just adding that to your already existing software for energy modeling or any of the other design related stuff that you have to do in a construction project.
Yeah, and I think the next step for us with Beam is to integrate it into those energy modeling softwares, so that right now you kind of do all the inputs once for your energy model, and you kind of have to repeat them all for Beam. But we're going to work on sort of being able to move that information from the sort of more common energy modeling softwares directly into Beam, so you can kind of get right to the good stuff without having to put in the inputs again.
Yeah, that's great stuff, and I hope everybody checks out your website and looks at some of your reports. I've always kind of been entertained by the different illustrations that you guys have and the stuff that you put out that shows trees being cut down in a forest or trucks moving material around. I think it does kind of help you follow along. But unfortunately, that's all the time that we have for today. Thanks for joining us, and thank you to all for listening. Please remember to send us your comments, questions, and suggestions to finehomebuildingpodcast@taunton.com. And please like, comment, or review us wherever you're listening. It helps other folks find our podcast. Stay safe, everybody, and thanks again for listening.